Hi guys and welcome back to another video. Today it is day 89 on hashtag ASR 99 days data science challenge, and today in this video we are going to look at principal component analysis. Principal component analysis, that is PCA, is an unsupervised technique which is used to examine the interrelations among a set of variables in order to identify the underlying structure of those variables. And PCA is also generally known as the general factor analysis. We all know that a linear regression model is used to find the best fit line, whereas our PCA helps us to determine the several orthogonal lines, that is the perpendicular lines of the particular best fit line, that is the lines are perpendicular to each other in an n-dimensional space. So let me show you how this works. Let's take a graph like this, and then in which I have some random points, and now I'm considering this particular line as my best fit line. Now I will add a perpendicular line corresponding to this best fit line. So this would be something like this, and here it makes a perpendicular angle now. Here the components are some linear transformation that chooses a variable system for that data such that the greatest variance of the data comes to lie on the first axis, and it shows or explains the greatest variation. The second greatest variation is explained by the second component. So in this case we can identify the variation of this particular points with the help of this line, where it are actually explains around 70 to 75% of the variation in this particular points. And when we add this particular orthogonal line over here, this helps the previous line by explaining the remaining 20 to 23%, and the remaining points remains unexplained. This is because of the lower dimensionality, but when we increase the dimension to 3D or 4D, we can explain all the points. And this process allows us to reduce the number of variables used in the analysis too. If we use this technique in larger data sets with more features, such as our cancer dataset, which we used in support vector machines, I guess it is on day 85 or 86, I guess. If you haven't watched that video, do check it out, where we had 30 features. And now with the help of our PCA, we can compress these 30 features into 2 features and explain the variation with just these 2 features alone. We also need to standardize our data by some scalar for PCA, which we can perform with Python. We also used our standard scalar in the last video, that is on day 88. If you haven't checked that, also please do check it out. And now let's jump into our Jupyter notebook and try using our principal component analysis over there. And now let's import our necessary packages, that is import pandas as pd, import matplotlib.pyplot as plt, and then from sklearn data sets we have to import our breast cancer dataset. So type load underscore breast cancer, and we can also import our standard scalar from sklearn.preprocessing. So from sklearn.preprocessing import standard scalar, and finally from a scalar dot decomposition we will import our PCA. Here sklearn, and let's run this out. Yeah, we have imported our packages, and now let's load our breast cancer dataset. So let me name it in a variable C, and in which load breast cancer. And now let's look for the keys. C dot keys. Oops. And here we got some keys where it contains the data. This is the target variable, the data frame, and the target names, the description, the feature names, and the file name. So let's look at the description. We already know that what is in the description, so let's look at it again. Print DSCR. Let's run this out, and here is the description of this particular dataset where it has 569 instances with 30 features. And now let's create the data frame with it. So data frame, let's name it df, where pd dot data frame, and in which I will use my key data, caps small d data, and where I got all the data now, and I need to name the columns for them. So columns equals, my column names are the feature names. So let's copy this and see, in which I will pass the feature names. And let's run this out, and let's look at the first 5 rows of our data, and here they are. We have 30 columns. Now let's standardize our data with the help of our standard scalar. So we have imported the standard scalar package already, and now let's create an instance for it. So let's take a variable yes, and standard scalar, and we created an instance. And now let's train our data. So s dot fit, and in which I will pass the data frame df. Now we have to transform our data. So s dot transform, and in which I will pass my data frame df. And now let's look at the variable scaled. So scaled, and let's run this out. And here we can see that it is a numpy array with all the features in it. So now let's use our PCA. Let's say a variable PCA, and in which we have to create an instance for it, capital PCA, and in which I will pass the n components value. That is, n components is a parameter that we have to pass components, and in which I will set it to 2. That is, out of these 30 features in my data frame df, I will compress them, and my final output will have only 2 features. So now we have to train our model based on this scaled data frame. So PCA dot fit, and in which I will pass scaled, and let's transform this, and let's store it in a variable x. So PCA dot transform, where I will pass my scaled data, and let's look for our x. And now here we can see that it have only 2 features. So in order to check for that, let me show you the shape for it. So scaled dot shape, which is 569 rows and 30 columns, that is 30 features. And now let's look at the shape of my variable x, which is the same 569 rows but with only 2 features. That is, here we can see that the dimensions are reduced. And now let's plot these points in our scatter plot. So plt dot scatter, and in which my column 1, that is my first column, where I need all my rows, and then my first column, and the second value, that is which will lie on my y-axis, would be the second column, that is x of, in which I will take all the rows, and I will pass one for it. And let's name them. So plt.x label, which is the first component, and plt.y label, which is my second component inside the quotes. And now let's run this out. Oops, label. And now here we can see that we got our scatter plot for this. And now let's differentiate these points based on the target names. So we have the target name, so C of in which target names. So we have two target names over here. Either we have to tell that the particular patient is a malignant or a benign. So in order to differentiate that, let's use the parameter color and pass in our key target. So target, and let's run this out. And now here we can see that and this is the power of our PCA. And now when we train our SVM, that is support vector machines model, with the help of this dimensionally reduced data freq, now we can get an higher accuracy score. And yeah, that's all for today in this video. And in this video we looked at principal component analysis. Thanks for watching. Like the video, leave a comment down below, and let's meet on day 90.